First question here is, find the greatest common factor, GCF, of each pair of numbers. Use different methods. The first one, the two numbers are 16 and 8, right? So when you have numbers, one is 16, the other one is 8, right? What you notice, we know 8 is a factor of 16, all right? Or you can say 16 is a multiple of 8. So in this case, for sure, the greatest common factor should be what? It has to be 8, right? Greatest common factor. Factors are smaller numbers, right? So we have our answer 8, since 8 is a factor of 16 itself, right? So that is one way of doing it. The other way is to write factors, right? So we can write factors of 16. So we know 1 is a factor of 16. 1 times 16 is 16, correct? And then we know 2 times 8 is 16. And we know 4 times 4 is also 16. So these are the factors. As far as 8 is concerned, we know 1 times 8 is 8. 2 times 4 is also 8, right? Well, that gives you all the factors, and which is the greatest common factors? Well, you know the common factors, correct? So these are common factors. These are all the common factors. Amongst the common factors, the greatest common factor is 8, right? So we can say, confirm again that GCF, the greatest of all these common factors, is 8. Does it make sense to you? Correct? So that is the second way of doing it. Perfect. Now let's take the next example. I'll give you 3 different methods for sure. So the first way, and this is the second way for the first question, we'll elaborate more on different methods for example B and C. So now let's look into the factors of 10 and 35. So as far as 10 is concerned, the factors of 10 are, we know 1 times 10 is 10, and then we know 2 times 5 is 10. As far as 35 is concerned, 1 times 35 is 35, and 5 times 7 is also 35. So if you match this, what we see is 1 is always a common factor, correct? And the other common factor is 5. So these are the 2 common factors, out of which 5 is the greatest common factor. Correct? So this time we did this using the second method. Let me take opportunity to discuss the third method with you now. So we are looking into 2 numbers, 10 and 35. So we'll write down their prime factorization. 10 can be written as 2 times 5, and 35 can be written as 7 and 5. So this is prime factorization, correct? So what you got here is prime factorization. Now you can see from here that actually the common factor between them is only 5, and therefore that is the greatest common factor. We can actually combine it with the Venn diagrams, right? So let me draw 2 Venn diagrams. Let me draw 1 Venn diagram with 2 circles. So here we will write factors for 10, 5 being common. So 2 and 5 is common, correct? And that is for 35, 7, correct? So what you see here is that we have written the factors for the numbers 10 and 35, correct? The greatest common factor is 5. Do you see this number here? And so once again, we confirm that 5 is the greatest common factor. So that becomes your third technique to find the greatest common factor. For bigger numbers like 72 and 40, this is a very good technique. For smaller numbers, you can list all the factors and match. Perfect. So you can follow any of these techniques. I'd like you to now pause the video and apply the best suitable technique for part C, where we are looking into numbers 72 and 40. Well, of course, for 72 and 40, these are big numbers, right? So let me do prime factorization. So we'll do prime factorization. And then we'll use Venn diagram. Is that clear to you? So, as far as 72 is concerned, we have the numbers with 72 as prime number 2 can get into this. So 2 times 36, correct? So for 36, we can again split this, taking a prime number 2 times 18, and then with 18, we have again prime numbers 2 is a factor times 9, and as far as 9 is concerned, I could write 9 as 3 times 3. You see that? So 2, 2, 2, 3 and 3 are the prime factors for 72. Let us do the same for 40. Correct? So as far as 40 is concerned, we know 2 times 20 is 40. And then 2 times 10 is 20. So if I write like this, I kind of organize as I move. So this is a neat technique, right? So with my experience, I found that factoring and displaying the data in this fashion really helps, correct? Now we'll use the Venn diagram. So we'll write factors of numbers 72 and 40 in a Venn diagram, right? So we'll write down 40 on this side and 72 on this side. We'll work with the common factors. How many 2's? 1, 2, 3 2's, 1, 2, 3 2's, right? So we could write this number 2 cube here. 2 cube is 8, right? So which is basically what I'm writing here is 2 times 2 times 2, which is 8. Do you see that? So we have already taken care of these 3 2's. We're left with 1 5 for 40. And here we are left with 3 times 3, right? So we are left with 3 times 3, which is 9. Do you see that? So from here clearly, we get our result that the greatest common factor is 2 times 2 times 2, which is 8. So in the Venn diagram, you see it right in the middle as shown here. So you see there are a couple of ways of finding the greatest common factor. Globally, we use different methods. You can adopt this last method of prime factorization in Venn diagrams, especially when we are working with bigger numbers. I hope that makes sense. So we'll take a small break here. I hope this concept of finding greatest common factor in many different ways is absolutely clear. Feel free to write your comments, share your views, and if you like and subscribe to my videos, that would be great. Thanks for your time and all the best.